Okay, we're going to put the derivative to work in this problem. There's different uses that we have for the derivative. What we're asked to do here is examine the following. What is the slope of the given curve at the given point? This is an absolutely wonderful fit for the derivative because the derivative is the tool, it is the function that tells us the slope of a given curve at a given point. So this is really the right tool for this problem. Okay, let's examine what this means though. Let's make sure we understand it. So we have the given curve here is f at x equals half x squared plus 2x plus 3.5. And we're going to talk about that curve at the point -1, 2. So I actually took the opportunity to graph that over here in Sketchpad. So if we notice here, we have that the point on this curve, point A, will move around. And if we see this, there's a line that's tangent to the curve that is through that point. And if you notice as I move, change the x value of that point, the y value changes as well. And the tangent line is changing with it. Okay, but specifically we want to talk about at this point, if you notice up here, the top of the screen, it says A is -1, 2, which is the point I want to talk about. So as I talk about what is the slope on the curve at that point, I'm really talking about the slope of this tangent line at that point. So that's what I'll be computing by using the derivative. Now the process is very mechanical. It's very straightforward. It's only 2 steps that we have here. It says compute the derivative and then evaluate the derivative for the given value of x. So it's only 2 steps. So we can get right to work on that and see that we've got f prime of x is going to be the power rule we'll use on this function. So it's going to be 2 times a half is 1 times x to the first plus, now we've got the power rule done to a linear term, so we're just left with the coefficient. And then the power rule done on a constant term is 0. The last term being that constant of 3.5. So a pretty straightforward power rule process. It's something you should have mastered as you go into these problems that require you to use the derivative. And now we're going to use this x value, as it says in step 2. So we're going to do f prime at -1, which is equal to -1 plus 2. This gives us 1. So what we're saying is the curve f at x has a slope of 1 at the point -1, 2. Okay, so let's go and examine the point -1, 2 and look at the tangent line through that point. And let me just change gears here a little bit with my tools. Okay, so again, we have the point -1, 2, and we see this tangent line. Well, if you examine this function closely, this tangent line closely, excuse me, you'll see that if I just took 2 points off the line, you would get a rise of 1 and a run of 1, which makes the slope, rise over run, equals 1 over 1 is 1. So it's just exactly like we computed. So again, the 2 steps you need here are to compute the derivative and then evaluate the derivative for the given value of x. Okay? I hope this places a premium in your mind of computing the derivative. You have to be a power rule master at minimum to do these problems for the pre-calculus class that we're studying them in. Okay? Enjoy.